We'd like to thank Cloud Foundry, our sponsor, for these podcasts from Cloud Foundry Summit in Frankfurt, Germany. Cloud Foundry gives companies the speed, simplicity, and control they need to develop and deploy applications faster and easier. It's open source, easy to iterate, and built to scale. Learn more at cloudfoundry.org. Hey, it's Alex Williams, the New Stack, here at the Cloud Foundry Summit with Andreas Noras. Is that correct, Noras?
That's correct.
And Michael Berendt, also of IBM. Hi, how are you guys?
Good, how are you?
Good. Good, I wanted to talk about OpenWhisk and the serverless architecture behind it. Could you explain OpenWhisk, what it is, and its architecture and what makes it unique?
Yeah, absolutely. So, crisp and to the point, maybe first explanation. It's an event action platform that allows you as a developer to execute code in response to an event. So you have some kind of event, some kind of trigger coming from maybe a Bluemix service or any other service, and that causes application logic to be kicked off that a developer has written in any of the language that we support. We currently have we offer this as a commercial service running on top of Bluemix, so you can directly go to Bluemix and start playing around with that. We are currently in beta stage, but you can also go to our open source offering, which we have hosted on GitHub, so you can have a look there, you can provide feedback, and of course we encourage you to do that. We even want you to participate and to contribute to accelerate the development of this technology. So what it makes unique, I mean, it's falling into the entire field of serverless computing, of course.
And there's so many of them out there. I'm curious on how it differentiates from a Lambda or Google's platform or any of the other number of vendors out there.
So maybe one of the main points. Go ahead.
There is a number of differentiators that we have. The first one is already the one that Andreas mentioned. We are developing it entirely in the open. So it's out there on GitHub. The code that we are running in production in Bluemix is the one that we have out there. It's the same set of people that we have in the team that are developing the product. We have an open event provider ecosystem, which means most of the other platforms don't allow you to bring in your own event providers. If you have an event provider that you build or that you want to use in a custom fashion, you cannot plug them into the other serverless platforms which are out there. With OpenWhisk you can. Some other aspects that are very important is we are supporting Swift, server-side Swift, as an action language, which is very appealing to mobile developers on the iOS side out there. They can use the same set of skills they have for development, both for apps on the device and on the server side.
So there's a server-side Swift integration, and that's really new, isn't it?
It is really new. We launched it as part of the first launch of Bluemix of OpenWhisk in February this year, and we are now working on the Swift 3 integration. Swift 3 just GA'd last week, so very soon we'll have support also for Swift 3 in the OpenWhisk implementation.
And you chose Swift due to its popularity on mobile iOS, for iOS developers.
I mean, there are a couple of reasons, so Michael already mentioned it. It makes it so easy for mobile developers to outsource, for example, compute-intensive tasks to a scalable cloud platform without the need to learn a new language, for example, so they can reuse existing skills. And I think this is, especially in the mobile context, a big advantage. So that's why we thought, let's make Swift one of the languages that we support, and in which you can implement these little actions that contain the code that is supposed to be kicked off if there is an event coming in.
So what is the connection with OpenWhisk to, for instance, some of the advantages we hear about for serverless, environments? We hear it's used for mobile applications. We heard it's like it's effective for stateless, type of environments. We also hear of it, somewhat effective for maybe even IoT, right? Yeah. For batch processing, as an example. Does that cover it for OpenWhisk, or is there more to it that you would say?
I think what we have to understand is what's the general sweet spot for OpenWhisk
Right.
workloads. And the sweet spot for OpenWhisk workloads is workloads that are spiky in nature or don't have homogeneous load, which is the majority of the workloads, and workloads that you can break down into small tasks or is not by nature broken down into small tasks. You touched on a number of workload characteristics. Mobile backends is a good example. Data processing, all kinds of scatter-gather workloads, something you would have implemented with MapReduce in the past, where you break down large tasks into small ones. Due to the inherent scalability of OpenWhisk, those workloads are very suitable. Like if you want to analyze a video, you break it down into its frames. Each frame gets analyzed by a single action. You gather the results again and return them back to the user. IoT is a very good kind of workload you already mentioned. It's very event-driven in nature. Cognitive workloads, if you need to do object recognition on pictures, video recognition, text detection in audio files, all kinds of those kinds of things. And bots as another workload that is emerging, because bots are also very event action driven. So serverless is very well suited for that.
That's interesting. So just thinking through what you're talking about, you're talking a lot about the functions that Whisk can help you execute on, right?
Yeah.
And does it also? There's also when people talk about serverless architectures, they talk about the back end as a service environment. What's the crossover with OpenWhisk? What is that? You know, is that part of the sweet spot, like the back end as a service?
It's part of the sweet spot. One workload that is also critically important, which I haven't mentioned yet, is microservices. Because in my mind, the only really scalable way of implementing microservices is a serverless architecture. So why I'm saying that? If today you have a monolith, you break it up into, let's say, 50 microservices. Each of them is running in a traditional architecture in a container. Each of those containers should be HA, so you have 100 containers running. You might want to run it across multiple regions, so you have 100 or 200 containers running across those regions. So the more you break down your applications into microservices, the more infrastructure cost you have to pay for. With the serverless architecture, you can break it down into 1,000 microservices. You don't pay a penny more or a cent more, because only when requests are coming in, code is running in memory and you get charged for it. So I think what we'll see in the future is a heavy adoption of serverless in the microservices world, because it's by orders of magnitude more cost efficient.
Mm-hmm. So I'm curious then, you know, what is OpenWhisk really not meant for? We know that serverless architectures have a lot of uses like you've described, but it's often not really applicable to stateful environments or really on-premise environments as much either. Yeah, I mean, I'm sure that's up for debate. I have heard that as one of the
I think it's
issues
a very
with
good point, actually.
Yeah,
I think it's a very good point. Like, I wouldn't know how to run a MongoDB cluster on a serverless platform today.
right.
I wouldn't know how to, or a zookeeper cluster, or a relational database like MySQL. I think those kinds of workloads are not really well suited for serverless platforms. To your point about on-premise, I think the jury is still out, but I think the economical benefits of using a serverless platform can really only be leveraged if you don't have to pay for the infrastructure. The by millisecond charging is much more attractive on an infrastructure where you get charged by the millisecond and you don't have to pay for all the other resources, versus doing it off-prem.
So there's lots of, okay, go ahead.
And I also think it often might not be the perfect solution if you have very long-running processes.
Right.
I mean, it's about coming to optimal utilization. So if you want to build something where your VM, for example, is under load and utilized heavily, so they already have a 90% utilization, then a VM might still be a good way to go for. But if you have very often scenarios where load goes down and load goes up, and it's unpredictable when it goes down and when it goes up, so that you need to be able to very quickly scale out and scale down again. I think these are typical scenarios where serverless can help, because you then do not have to pay for all the overcapacities that you need only very seldom.
Okay, so another topic that people are discussing with serverless architectures is what is it really hiding for that developer, right? There's a lot of work going on behind the scenes, with that serverless environment.
Yeah.
So that that could be, and there's an upside to that, but there's also a downside, right?
Yes.
And some of the downsides, for example, are issues with monitoring, right, and logging. What are some of the primary challenges that you see you're going to be working to try to overcome, kind of, so it is more transparent, it is more understandable for people?
Yeah, I think there is no good and bad if you look at the various compute options, like their virtual machines, containers.
Right. It's not a moral issue.
Yeah, I think it's more of a fit-for-purpose kind of discussion. If you need lots of control, you usually go with virtual machines. There you can control which operating system you're running on, patch cycles. You get very deep insight into the infrastructure you're running on. If you don't need that level of control, but prefer having a level of abstraction that takes away work from you, you go more with a serverless model. There, you don't have to worry about patching of the operating system, security vulnerabilities that have to be fixed, monitoring of the infrastructure, capex in itself. You don't have to worry about scaling. I mean, in the traditional world, there is auto-scaling, of course. But still you have to understand, are you auto-scaling based on end-user response time, based on memory, based on CPU, what are the right thresholds? It's not trivial to properly configure auto-scaling. In a serverless world, you don't worry about that at all anymore, because for each request there is a new process launched, so it scales inherently. It takes that away from you. It takes away from you the resiliency aspect. Since there is no long-running process anymore, you need to make HA. You don't have to take care of that, and you don't need to pay for that additional infrastructure of the additional process that you're running. So, in my mind, it's really not a good and bad. It's more like understanding the pros and cons, trading off, trade-off between control and abstraction.
Right.
And I think it's important to decide how much flexibility do I need. So if I go with a VM, for example, I have all the flexibility. I can pick the CPU I want, I can pick the memory I want, but the price for any flexibility is complexity. So if it's more important for you to get started easy, then you might more go towards a serverless solution that hides all the things that I've mentioned, like infrastructure and operational complexity.
I guess one of the questions that I also have is about the programming languages that are available with serverless architectures, and there's been very popular with Node. I mean, Node.js is not a server, it's a server-side JavaScript, but that's a little bit different. But is that a focus area for you to kind of extend the number of programming languages you can use with OpenWhisk? Is it not really an issue? Are you focusing on Node.js at all?
So today we have Node.js support, we have server-side Swift support, we have Java support in a very initial form. We'll expand it over the next coming weeks and months. We have Python support, and we have support for developers to just come with their own custom Docker image, whatever it's contained in there, and run it as a serverless action, which is also quite unique feature compared to the other players in the industry. So that gives developers the ability to come up with any binary or anything that they have packaged in a Docker container. It's not as convenient as just using the natively supported languages, but it gives them more flexibility. I think what they have to understand is there might be a little bit of a performance trade-off in the execution if they come with raw Docker containers, but again, it's trading that against the control they're getting.
And I mean, long term, it's an open technology, right? So long term, our dream is
Right.
of course that people can, because we enable them to do so and we document how to do that, can even help us adding new runtimes in there. So it's not only that we as IBMers have to focus on the bringing or adding more and more runtimes. Even the community can help us to do that one day. That's nothing that is possible today, but long term we want to make
Yeah.
that possible, of course.
And one of our guys was at a meetup just recently in New York a few weeks ago, and there he demonstrated how easy it is to add an additional language. So it is technically possible. If folks out there are interested, they can send PRs. We are happy to look at them and integrate them as they fit. So it's not a closed system from that perspective.
I guess just the last just question I have is we're at the Cloud Foundry Summit, and and Bluemix is a Cloud Foundry environment.
Yeah.
Is there a connection between OpenWhisk and Cloud Foundry then?
There is. So what we wanted to ensure from the beginning is that there is and the user experience across Cloud Foundry and OpenWhisk that's as seamless as possible. So we want to make sure that once I have a user ID in Cloud Foundry, I can use the same user ID for OpenWhisk, of course. Once I have an org and a space, which is a Cloud Foundry specific concept, an organizational concept, I can use those same orgs and spaces to organize my actions, as we call them, on the OpenWhisk side. So we implemented a piece of code, piece of glue code that allows us to run OpenWhisk and Cloud Foundry in combination and make it feel for the consumer that like it, as if they were integrated from the beginning.
Interesting. Well, Andreas and Michael, thank you very much for taking the time. Andreas, we've been trying to get this arranged for some time, so I'm glad we had the chance to sit down and meet in person and have a conversation about OpenWhisk. And Michael, nice to meet you. Thank you both for joining us.
You're very
Thanks for
welcome.
having us. Thank you.
We'd like to thank Cloud Foundry, our sponsor, for these podcasts from Cloud Foundry Summit in Frankfurt, Germany. Cloud Foundry gives companies the speed, simplicity, and control they need to develop and deploy applications faster and easier. It's open source, easy to iterate, and built to scale. Learn more at cloudfoundry.org.